Imagine getting into a car, entering your destination, and simply sitting back while the vehicle drives itself safely to where you need to go. No steering, no stress about traffic, and no need to focus on road. My name is Tyson Paul, and I am a Year 2 Creative Computing student. In this presentation, I'll be exploring the topic of driverless cars. So let's get started. Introduction to driverless cars. So this is the idea behind driverless cars, also known as autonomous vehicles. These vehicles use advanced technologies such as artificial intelligence, sensors, cameras, and machine learning to operate without human control. Driverless cars are considered one of the most important emerging technologies in transportation today. They have the potential to completely transform the way we travel, from improving road safety, reducing traffic, and increasing accessibility for a wide range of users. In this presentation, I will explore how driverless cars work, their development over time, the key companies involved, the problems they aim to solve, the potential benefits, and the challenges this technology may bring to society. How does it work? Driverless cars operate using a combination of advanced technologies that allows them to understand their surroundings and make driving decisions. One of the key technologies involved is artificial intelligence. AI enables the vehicle to analyze data from its environment and decide how to respond, such as when to slow down, stop, or change the direction. Another important component is the use of sensors, cameras, and radars. This continuously scans the surroundings to detect vehicles, pedestrian, traffic signals, and obstacles. Machine learning also plays a major role. By learning from large amount of driving data, the system improves its performance over time and becomes better at handling real-world situations. In addition, these vehicles are connected through the Internet of Things, allowing them to communicate with other vehicles and traffic system, which helps improve navigation and safety. Timeline of development. The concept of driverless cars has been developing over many years. Starting from 1915, the concept of autonomous vehicle is first introduced by General Motors at the Motorama show, showcasing a self-driving car model. The next is 1980s. The first successful experiment with driverless technology occurred at Carnegie Mellon University, paving the way for future development. The next is 2004. The DARPA Grand Challenge takes place, encouraging advancement in autonomous vehicle technology and attracting various teams to compete. On 2010, Google's self-driving car project is officially announced, marking a significant leap in public awareness and interest in driverless technology. On 2020, various companies including Waymo and Tesla began offering limited driverless ride-sharing service, showcasing practical application of the technology. In 2023, a significant legislative advancement occurred worldwide, with many regions implementing regulations for the testing and use of driverless cars on public roads. So today's driverless cars are being tested globally, and some autonomous features are already available in modern vehicle, showing how far the technology has progressed. So next is, who are the key players? Several major companies are leading the development of driverless technologies. So Tesla is one of the most known companies in this field. It uses artificial intelligence and machine learning supported by real-world driving data collected from its vehicles to improve its autonomous system. Waymo, this is part of Alphabet, is another key player. It focuses on highly advanced autonomous system using sensor, cameras, and mapping technologies to navigate safety. Volkswagen is also working on integrated machine learning and connected vehicle technologies to develop smarter driving systems. Similarly, General Motors is using advanced technology to analyze road conditions, predict hazards, and connect vehicles with digital infrastructure to improve safety and efficiency. Why are we using it? The main reason for developing driverless cars is to improve safety and efficiency on the road. Most traffic accidents today are caused by human errors such as distraction or poor decision making. Autonomous vehicles aim to reduce these risks by removing the human factor and relying on precise data driven systems. Another key benefit is accessibility. Driverless cars can provide mobility for people who are unable to drive, including elderly individuals and people with disabilities. In addition, they can make travel more convenient and productive as passengers can use their time more efficiently instead of focusing on driving. What human problem is it solving? Driverless cars are designed to solve several major problems in transportation. One of the biggest issues in road safety, since human error is leading cause of accident, autonomous system can help reduce crashes by consistently monitoring the environment and reacting quickly. Traffic congestion is another problem. Autonomous vehicles can communicate with each other and optimize routes, which help improve traffic flow and reduce delay. They also address mobility challenges by providing transportation options for individuals who may not be able to drive themselves, making travel more inclusive. What human desire does it fulfill? In addition to solving problems, driverless cars also fulfill important human desires. One of these is the desire for safety. People want to feel secure while driving, and autonomous vehicles aim to provide that by reducing risk associated with human driving. Another important desire is convenience. With driverless cars, people can relax, work, or enjoy entertainment during their journey instead of focusing on road. This makes driverless transportation not only safer but also comfortable and efficient. What impact will it have? Driverless cars could have a significant impact on society. They have the potential to make roads safer, reduce accidents, and improve overall transportation efficiency. They may also benefit the environment by reducing traffic congestions and fuel consumption. However, there are still concerns regarding safety, reliability, and legal responsibility. These issues need to be addressed before autonomous vehicles can be fully integrated into everyday life. Why not use it? Despite the benefits, there are several reasons why driverless cars are not yet widely adopted. Safety concerns remain a major issue, especially in complex traveling conditions such as poor weather or unclear road markings. There are also regulatory challenges as governments are still developing laws, policies for autonomous vehicles. Trust is another barrier. Many people are still unsure about relying on automated system for something as crucial as driving. In addition, there are economic concerns, including the cost of technology and its potential impact on jobs. Key statistics: understanding the impact of driverless cars through crucial safety, efficiency, and adoption metrics. 94% of traffic accidents are caused by human error. 10x lower accident rates expected with fully autonomous vehicle. 80% of consumers are interested in using driverless cars according to recent surveys. 1.2 million people die in road accidents each year globally, highlighting the potential for driverless cars to save lives. 50% of all vehicles fatalities could be prevented with the widespread adoption of driverless technologies. What obstacle does it face? Driverless cars face real-world challenges that affect their performance. In some regions, poor road condition, unclear markings, and unpredictable traffic behavior make it difficult for autonomous system to operate efficiently. These vehicles depends on clear infrastructure and reliable data, which is not always available in every location. As a result, some countries have restricted the use of certain autonomous features until the technology become more reliable. What problem might it create? Driverless cars may also introduce new challenges. For example, in complex environment, the system may misinterpret situations which could increase the risk of accident. Another important issue is legal responsibilities. In the event of an accident, it might be unclear who's responsible, the driver, the manufacturer, or the software. With clear regulations, these issues could create legal and economic complications. Challenges and solutions. Safety concerns, ensuring the reliability and safety of autonomous system to prevent accidents and malfunctions. Public acceptance, building trust with consumers and the public to embrace driverless technologies such as viable options. Regulatory hurdles, navigating complex legal frameworks and obtaining necessary approvals for testing and deployment. Technological limitations, overcoming current technological barriers such as perceptions, decision making, and environment adaptability. Ethical consideration, addressing moral dilemmas associated with decision making in critical scenarios during accidents. As Andrew Ng once said, self-driving cars are one of the most exciting applications of machine learning. They have the potential to save millions of lives. This highlights both the potential and importance of these technologies. In conclusion, driverless cars represent a major advancement driven by artificial intelligence, machine learning, and the Internet of Things. These technologies allow vehicles to make real-time decisions, learn from data, and communicate with their environment to improve safety and efficiency. Although challenges such as safety concerns, regulations, and public trust still exist, the potential benefits are significant. With continued development and responsible implementation, driverless cars could transform transportation, reduce accidents, and create a more accessible and efficient future. Thank you for listening.